Alright, this video is about how to rewrite equations so that they are in slope-intercept form. So, slope-intercept form is a very useful form for linear equations, and sometimes you'll have equations that are not in that form, but you really need them to be in that form. So I'm going to give you several examples of equations that are not in that form, but that we could rewrite and put in that form. Okay, so here is your first example. So let's say we have 2x plus 3y equals 8. So if you'll remember, slope-intercept form is y equals mx plus b. And so the thing to notice about that is that I need the y all by itself. That means if there's anything else on the same side with the y, then I need to move it away. So in this example I have, we need to take this 2x, and since there is not a negative in front of it, then it's a positive 2x. And I need to do the opposite or inverse operation, and I'm going to subtract it from both sides. So when I subtract it, 2x minus 2x means it's not on the left side anymore, but I just have the 3y over here. Now on the other side, notice that the 8 does not have an x with it, and the 2 does. So those are not like terms, and I cannot put them together. So this is just going to be negative 2x plus 8. You could write it as 8 minus 2x, but if you remember, slope-intercept form is y equals mx plus b. The x part is first. The constant term is at the end, so I'm going to go ahead and write it in this way. Alright, so I need this to be just a 1y, not a 3y. So I'm going to take the number in front of y, and I'm going to divide all of the parts, or all of the terms, by that 3. So 3 divided by 3 would make this just a 1y. And this is going to be a negative 2/3 x plus 8/3. Now, if you wanted to, you could change that 8/3 so that it was a mixed number, but you don't have to, so we'll leave it like that. We're not going to change them to decimals, we're going to leave them as fractions. So now it's written in slope-intercept form. Okay, so let's look at another example. So let's say we have a negative 6x plus 2y equals negative 10. So just like on our last problem, I need to move this x term away. This time it's negative, so I'm going to add the 6x to both sides. That's going to give me 2y equals 6x minus 10. And then I'm going to divide everything by the 2 so I can get the y all by itself. So 2 divided by 2 makes that a 1y. 6 divided by 2 makes this a 3x. And 10 divided by 2 makes that a 5. So y equals 3x minus 5. Okay, so here's another one. 7x equals 5y plus 30. So, most of the time, it seems like we have that y on the left side of our equation, and this time it's on the right. So that's okay, we can deal with it that way. You can subtract the 5y and move it to the left, or I could go ahead and do what we did before, and I can just subtract that 30 to get the y by itself. So that's what I'm going to do right now. So then I would have 7x minus 30 equals 5y. I couldn't put those two terms together since the 7 had an x and the 30 did not, so they were not like terms. Divide everything by this 5. If it doesn't divide out to make a whole number, then I'm going to leave it as a fraction. So this is going to be 7/5 x minus 6 equals y. Now if you're thinking I thought the y had to be first, I can just switch and write these on the other sides of the equation. So I could write y equals 7/5 x minus 6. So now that's written in slope-intercept form. Alright, now let's look at this one. Y minus 4 equals 2 times x minus 7. Alright, so in this case, I'm going to need to take care of this parentheses before I start moving things around. So I'm going to take that 2 and I'm going to distribute it. That means I'm going to multiply it times everything inside the parentheses. So 2 times the x and 2 times that negative 7. So if I do that, this is going to become y minus 4 equals 2x minus 14. Okay, now let's look at what I need to do to get the y by itself. The only thing that's over there with the y is this minus 4. So I'm going to add 4 to both sides, the opposite of what it was. And if you look on the right, since this is just a plain 4, I should be able to put it with this 14 that's there. So I'm going to put it under the negative 14. Okay, because it's going to be a like term with that. So negative 4 plus 4 is 0. This is just a y equals now. Negative 14 plus 4 is going to make that minus 10. So y equals 2x minus 10. All right, and one final example. Negative 3y plus 12 equals 4x. So I want my y all by itself. So I'm going to move the other term away from it. So we're going to subtract the 12 from both sides. 12 minus 12 means it's all canceled out on that side now. So negative 3y equals 4x minus 12. I couldn't combine them since one had an x and the other didn't. I'm going to divide everything by negative 3 so that I can get that y all by itself. All right, now this is going to be 4 divided by negative 3, so I'm just going to write that as a negative 4/3 x. Okay, so keep in mind that it doesn't really matter where that negative is located, just that there's only one negative. So if I write it with the numerator or with the denominator or out in front of the fraction, it's still the same thing. And then negative 12 divided by negative 3 is going to make this a positive 4. So y equals negative 4/3 x plus 4.